Okay, welcome to your first geometry lesson online. Um, we are going to start to build kind of a core foundation for all the words that we use in geometry and kind of build a vocabulary up, learn how to write geometric terms and things like that, okay? So when we start here with something like this, we want to kind of think of it as, what comes to mind when we think of points. So for me, that would be like, the word spot or, a location or some fixed, thing. Obviously, like just a thing like that, all right, would represent a point, right? You might point at someone, all right, meaning right there, right, a specific spot. If we think of lines, right, we're good with that's a straight line. Lines can go on forever, right? They're straight, they don't bend. That's a kind of important characteristics of a line. And when we think of a plane, other than a plane that flies in the sky, which is not what we're talking about, I think of like maybe a flat surface or something along those lines. Okay, so that kind of gets our minds thinking about what we're talking about, and now we have to look at how would we actually write these things in geometry, because we don't want to write them as what I've drawn up here. All right, so in order to write them, we got to know some vocabulary. So the ones that you probably have never seen before are the words collinear, okay, the word coplanar. Postulate you probably have never seen, or if you have, you might not know what it is, or axiom. These two are pretty much the same thing, okay? And we'll tell you what they are as we go through, but just giving you some pronunciation there as we go through. That's collinear, that's coplanar, postulate, and axiom, okay? All right, next slide. So in geometry, all right, most things are undefined until we define them. Okay, and how we define them is called something called nomenclature, or how we put them down on paper so you could look at it and say, oh, that is line AB, or that is a plane, or so on and so forth. Okay, so we have to learn how to do that. So the first one we're going to do is nice and easy, is a point. So if I have a point on the paper here, oops, like that, okay, I can't just leave it like that. I have to label it. So that may be point A. Okay, this over here might be point F. Okay, and that's how we write points in geometry. Okay, now the set of all points, all right, is called space. So maybe the space in the room I'm in right now is the set of all points in this room. Okay, so that's how we define space. And then the other important thing to remember is a point doesn't have any size. Okay, so in terms of geometry, all right, point doesn't take up any space itself. It doesn't have any size. Okay, and that's a little weird to think of, like how can all the points in a room be in a room if they don't take up space? But don't try to think of it too literal. But that's what we're talking about. Okay, so that's point. Now we go into things, they get a little bit trickier, okay? And it's very specific when we define a line, how we write it, okay? So this line right here, how do I know it's a line? I know it's a line because it has an arrow here and it has an arrow over here. All right, so that means it goes on forever. And then I have 2 points on that line, and then I have a letter T up here. Okay, now the letter T you might not be able to see because I wrote over it, but there we go. All right, so now we have the letter T. So the ways we could write this line, okay, are, and it's written down there for you, but we could write it as line AB. But I can't just write the AB. I need a symbol up above it to tell it's a line. So the symbol for a line is this. If it only has one arrow, it's not a line. You need this symbol, guys, okay? If you don't have that, it's wrong. Now, the other way to write it is the order doesn't matter when we're talking about a line because they go on forever. So if I say line BA, I could still draw this. I would know it passes through B, through A, and it goes on forever. So the other way to label that would be BA. And then there's a third way, okay? If you have a letter over here with no point attached to it, we can just write the word line T. Okay, and you'll notice as you go through geometry, they're going to be all lowercase when they're talking about lines. Okay, now when we talk about planes, all right, very similar. This P does not have a point here, so when you have a capital letter on a plane, this is a plane right here, we can just call it plane P. Okay, now here is one of the trickier things. When you want to use points to define a plane, you have to have 3. So that's something that you would want to write down. If you maybe pause the video, but you have to have 3 points to define a plane. All right. If you do not, you can't call it a plane. So I could not call this plane AB or plane AC or plane CB. I can call this plane P because that's not a point. It's a letter that's determining the definition of this plane. But over here, I have points A, B, and C. I have to use all of them. Now, you could call it plane CBA, BCA, BAC. Okay, the order does not matter, but you have to have 3. Very important. Okay, you'll see that again on a quiz or a test. Okay, now points and lines that are on the same plane are called coplanar. Okay, and that's one of the vocabulary words that we talked about. And I probably didn't touch on it above. When you have points that lie in the same line, those are called collinear. Okay, so points on a line are collinear. Points on a plane are coplanar. Okay, moving on. Okay, if we have to identify collinear points, okay, get out of your head that they have to be on the visible lines. Okay, you could draw a line through points and they could still be collinear. So they don't even have to be on the same line, unless I might ask you, are points E, F, and C collinear on line M? Yes, they are. Okay, but points F and P are also collinear because you could draw a line. Oh, that's a horrible line. Hold on. You could draw a line through those points. Okay, the line does not have to exist. So E and F are collinear points. They're not collinear on line M. They're not collinear on line N. They're collinear on the blue line I just drew. Okay, but that's also important. When I ask you if points are collinear, they don't have to be on the visible lines on the page. They could be collinear on a line that's not shown. All right, so that might be something you also see on a quiz someday. Okay, because that's an important point. All right, so I'll take that off. And let's ask questions here. Are points E, F, and C collinear? Okay, so even though you don't see that point, there is a point at an intersection, right? So we have points E, F, and C. They are collinear. And if so, name the line on which they lie. So the line on which they lie could be a bunch of ones, right? It could be just line EF with our symbol. It could be the word line M, because that M is over here. Right? Could be line CE, line CF, line FE, line, I don't know, FC. Okay, as long as there are points on that line, as long as you have that symbol, it's correct. And if you're going to use the word line, you can only use the letter at the end. Okay? Now, we want to know, are points EF and D collinear? Well, EF and D are right here, and right here. Right? So those are not collinear because I can't draw a line straight through all those. So that would be no, they are not collinear. Okay? So our points F, P, and C collinear. Okay, so you could pause this for a sec if you want, try and answer it, and then I'll answer it for you. All right, so they want to know, are lines F, P, and C collinear? If you want to pause it and try and answer it, do that now. And here comes the answer. So F, P, and C are not collinear, okay, because they're not on the same line. Lines F and P, points F and P are collinear. F and C are, and even C and P are, but not F, P, and C, okay? Now, name a line M in 3 other ways. We kind of already did that, right? We talked up here about line M, and then we said it could be EF, FE, EC, CE, FC, CF, as long as you have that symbol on the top. Okay, and why do you think arrowheads are used when drawing a line or naming a line such as EF, right? And that's just because we want to show that they go on forever. Lines do not end. So the arrows mean it goes on forever. All right, moving along. All right, each surface of the ice cube represents part of a plane. Name the part represented by the front. So how many points do we need? Do you remember? 3, right? So 3 points we need in order to define a plane. So one way would be the word plane and then pick 3 points on the face of the cube. Well, this is the face of the cube, right? Right here. So points E, F, B. That would be a plane. Or EFA or EAB. Any of those. I'll go with EFB. Okay. Name 3 different names for the plane represented by the top. So maybe pause it and try and come up with 3 on your own. You can do that while I shade it in. So here's the top of the cube, right? So what are 3 different ways there? What'd you come up with? Well, E, H, G. We could have plane E, G, F. Now, you could not say E, G, H and say that this is 2 different ways of doing it, all right? Because you're using the same letters. So you got to use different letters. So we have EHG, all right? We have EGF. We have FEH. Okay? So those are 3 different ways of naming the cube, okay? The top of the cube. All right. So a couple of other words that we probably didn't know, but a postulate or an axiom is an accepted statement or fact, right? It's something that we don't have to prove in geometry. Everyone accepts that it's true. Okay, so postulate 1, is through any 2 points, there's exactly 1 line. Okay, so it doesn't matter if it's those 2 points or if it's this point up here between points A and C, there is exactly 1, line. Okay? So I do not expect you to know what postulate 1 is. I expect you to understand it, but I'm never going to ask you what is postulate 1, and then you have to define it for me. Okay? But I might say using postulate 1, right, through any 2 points, exactly 1 line, explain to me why such and such is true. Okay? So I don't need you to come up with which one's 1, which one's 1, 2. I just need you to know they exist. All right, if 2 lines intersect, then they intersect in exactly 1 point. You cannot draw me 2 lines that intersect that cross at more than 1 point because lines are straight, and straight lines, when they cross, only create 1 point. So that's another postulate. All right, moving along. If 2 planes intersect, then they intersect in exactly 1 line. Now, this is a little tricky to think of, okay? These planes, while we're showing them like this, these planes go on forever. They're infinite. So the purple plane goes out that way and that way forever. And so does the green plane, okay? But we have to stop it in a picture, right? So, it looks like this, which kind of makes it look like it doesn't go on forever, right? But when we have planes, it does go on forever. And that's why point S and T are on that line. And that's why it's a line right here where they cross, not a line segment. Okay, so where does plane RST and plane STW intersect? It intersects at line ST. So that is another postulate. Okay. And lastly, postulate 1, through any 3 non-collinear points, there's exactly 1 plane. So think of that for a second. If I drew 3 points that were collinear, okay, there's a lot of planes that could go through that. Picture this line right here. If it is collinear, we could draw a plane that goes through it like this. We could draw a plane that goes through it like that. There's lots of planes that could go through that. Okay. However, if I erase that and I give myself 3 non-collinear points, the only thing that could go through that is 1 singular plane. And that's why when we name a plane, we need 3 points. Okay, because 3 points always define a plane. You can't draw me 3 points that aren't in a straight line that form more than 1 plane. Okay, so that's another postulate to understand. All right, so here's some more Examples. Find the intersection of two planes. Now remember, the planes go on forever, so the intersection's always a line, even though it looks like a line segment. Okay, so what's the intersection of HGFE? HGFE is the top plane, and BCGF is this side plane. Where do they intersect? They intersect right here, right? So what is that purple thing that they intersect at? That is FG, and it is a line. Okay? All right. So moving on. Name two planes that intersect in BF. All right. So if we look at line BF, let me erase this stuff. And we look here at line BF, that's here. What are the two planes that intersect there? Well, the front plane intersects there, and the side plane intersects there. So let's define the front plane. Plane E, F, A, and plane, the side would be F, G, C. Now, are there other ways to do that? Yeah, sure. I could have called the side GCB. I could have called it CBF. I could have called the front one BAE. All right. So your answers, if you tried that one on your own, your answers will vary. All right. There's lots of different answers. The key being you need how many points? Everybody should say it out loud. 3 points to define a plane. Okay. Shade the plane that contains A, B, C. Okay. That is right here, right? The bottom. Shade the plane that contains EHC. So that's a tricky one because it's an internal plane, right? It's this one here. It's this diagonal because it's EHC. There's that plane right there. Okay. So maybe try number 4A and B. Pause it and come back and let's take a look at the answers. All right. Name another point that is in the same plane as points A, B, and C. Okay. So the other point, kind of hidden in my drawing, is back there is point D. So the other point that's on that plane is point D. That's how we would write that. Name another point that's coplanar, right? Meaning on the same plane as EHC. So this would be point B. So you really have to understand what I'm asking for, right? I see have a lot of kids that give me lines when I'm asking for points or line segments when they ask me for lines, right? So always pay attention to what we're asking. Okay. This is the work we're going to do in class tomorrow. All right. Hopefully some of that stuff makes sense. You do not have to do this tonight. All right. If you want to take a peek at it, you can, but do not do it. We're going to do it in class, and we're going to work on some IXL stuff in class. I just wanted you to get an idea for what an online lesson looks like. Okay. So if you were taking notes on this, go back and do a quick recap. Some of the notes I would have is I'd probably have the word point down. I'd have the word line down with an example of each. I'd also have the words written on the side maybe that says arrows very important, symbol very important to have. Something like that, right? I'd have the word collinear and make sure I understand what that is. The word plane, coplanar. I would definitely have this written down, okay? And those would be kind of your notes as you go through. Once you come into here, I would have watched me maybe talk about these examples, pause the video, try and do these yourself. Same thing here. I did this one with you, pause the video, try this one yourself, compare it to my answers. All right, and likewise in this one. Okay, look through these postulates, make sure we understand what they are, and so on and so forth. Okay, so if your notes look something like that, you're doing a good job. We'll go over it quick tomorrow because it's important to get a good foundation because we're going to just add more vocabulary to this. So if we understand it, we should be in good shape. I will see you guys